Hi everyone, welcome to this continuous series on understanding sense of data and pre-processing steps. As you know, data science and machine learning, one of the major phases is your data pre-processing. One of the pre-processing technique that we will talk about today is encoding of the categorical variable. Let's get started. In the previous session, we talked about how do we handle outliers and cardinality assessment, how high cardinality and low cardinality can be an issue for machine learning. In today's session, I'll be focusing on encoding of discrete data or categorical data. Encoding of categorical data is a crucial step in the process of preparing the data for machine learning. Categorical variables are typically, the variables that have values that can be counted. For example, binary, nominal, ordinal, or label. In general, it is called discrete variable. These categories can be nominal. Nominal means no order. Binary means dichotomous, 0 and 1. Ordinal means there is some sort of order. Machine learning models typically require numerical input, so encoding is important and a necessary step in the pre-processing pipeline. So let's get started. And in this video, I'll show you the concepts and also, give you walkthrough hands-on Python code. So essentially, encoding categorical variable is a way to convert any string object or the object columns in Python to numeric. And one of the object column is categorical data, and you convert that into a numerical form. For example, creating a binary column for each of the category, we can choose to represent one of the categories as 0 and the other category as 1, sort of indicating presence or absence of each of the category. So some examples here of nominal categories: color, red, blue, green, amber, so on and so forth, gender, male, female, and city. All of the city the names that you could have in the data set can also qualify as nominal because there is no order. Animal type, again, example of nominal. Ordinal means there is some sort of order. For example, satisfaction rating: poor, fair, good, excellent. So there is an order here. So we can take the advantage of the order, and the numerical representation can be in this way. For example, the 0 can be attributed to poor, 1 fair, 2 and 3 and 4, and so on and so forth. So this can be one of the ways you can convert it to a numeric format. Binary variables, for example, subscription, subscribed or not subscribed, right? So you can choose to represent subscribe as 0 or not subscribed as 1. So let's take an example of how we perform some of the encoding methods. The first method is called one-hot encoding. In this method, let's say you have the color as a categorical column and the values are red, blue, and green. So we can convert into three columns. So since there are three distinct values in the color column, so those three will be converted equivalently to a column. So this one has a red, so that column becomes 0 and the other column will become, sorry, this column becomes 1 and the other column becomes 0. Similarly, blue, so the corresponding column will be 1 and the other column will be 0, and likewise green. So if you have 50 different values here, That means we are going to create 50 new columns, and this method is called one hot encoding or one OHE. So pandas provides functions. You can to that function, if you pass the column, it will read the column and find out how many distinct values it has, and automatically is going to convert it to dummy column. So this is also called dummy column. Sorry, I didn't explain that earlier. So these columns that you see here, these are called dummy column. Means the additional columns that we have created here. Next is the label encoding. Label encoding is straightforward. You have these labels, and you can arbitrarily choose to represent small as 1 or 0, or medium as 1 or 0 or 2, depending on your choice. So that's called label encoding. This is not really so useful when it comes to predictor column or the input column. The label encoding is okay if you have the categorical column, which is like, a label like a target or outcome or response variable. Ordinal encoding is where the column exhibits some kind of a pattern like high, medium, low, and then you can make use of the order and convert it to, let's say, high school to 1, bachelor's to 2, and master's to 3. So this is increasing order. So in that sense, we have numerical order also here reflecting the increase in the order here. Now the problem here is that the increase or the difference between the two is not not a factor or not a constant factor. That's the only problem with the ordinal encoding. Let's look at another encoding method. Is called frequency encoding, and these kind of methods are very good when we have nominal data. For example, city here, and let's say New York, Tokyo, London, Tokyo, and New York. Frequency encoding means it is something to do with frequency, and it assigns the value based on the frequency of each category. For example, here New York appears 2 times. So let's take a look at it. New York here and New York here. That's 2 times, and 2 divided by total number of samples is zero point 0.4, and that is what we have represented here, 0.4. Tokyo is also appearing 2 times, so that is also 2 by 5, 0.4. So you have 0.4. London appears 1 time, 1 over 5, that's 0.2. So you have 0.2. So this is a better way than one hot encoding. So if you're dealing with a large number of categorical values, then frequency encoding can also be looked at as one of the alternatives. So the interpretation of frequency encoding is higher frequency means the presence of more such instances of that particular value, and conversely the lower value indicates the category is not very common. One more method is called target encoding. Again, this is very useful for nominal data. It's also called mean encoding. Let's take a look at another example here. Let's say we have city, and the target means now we are going to consider the target column, like a response column. Let's say the value is New York here, and that this New York appears in class of 0. This one is class of 1. So it's basically mean of the target variable. So if you have here two targets like 0 and 1, so target encoding means the mean of the target variable. So what it means is, for New York, the mean of the target variable is just find out the places where the New York is appearing Here is 1, 0, and 1. So 1, 0, and 1, and that divided by 3 because the 3 is the number of places where New York is appearing. So the value is going to be 0.67. Tokyo, how many places? 0 and 1 and 1 and 0. So just add them up, divide by 4, so that's 0.33. And likewise, for other values also, you're going to convert it, counting how many places, wherever it is appearing in the target. So essentially, the target has to be defined and target should be numeric. And based on that, you can compute the encoding for the categorical variable. So the advantage of target encoding is it is very good when you have high dimensionality or the categorical column which has many values, a large number of values, and it reduces the dimensionality. Like in one hot encoding, if you have 100 categorical variables or values, then you're going to get 100 additional columns, which is not so here in the target encoding. So this will or this may improve the model performance. So there are some disadvantages also of target encoding, risk of overfitting, especially when the data set is small, like 1,000 samples or 5,000 samples. It's good when you have a very large data set. The impact of target imbalance can also be a problem. That means if a certain categorical value is more prominent than the others, then it will create some sort of a imbalance in the representation. So we should analyze for the equal distribution or uniform distribution of categorical values. Next, I'm going to show you the Python example for these encoding methods. Let's take a look at how we implement some of the encoding techniques we just discussed. I'm going to take a data set, and that data set has these columns. It's a automobiles data set, and the columns we might focus here, just for example, is the make of the data set, car, and number of doors, body style, drive wheels, and so on and so forth. There are other columns which we are not going to focus here. So pandas and numpy, and we're talking about a data set which is available on my GitHub. So I'll be attaching the code sample, and these are the columns here. So just read the data set into a data frame, and that's how the data set looks like. And we'll be looking at the number of doors here. As you notice, number of doors are categorical, is categorical column. The values are 2 and 4. So, and similarly, you make use of value counts to see the distribution of the categorical values. For example, in the make column, you have Toyota coming in 32 times and Nissan, 18 times, and so on and so forth. So as you can see here, in this particular case, the column make is not balanced one because you have only one instance. So such, the assessment of the categorical values is important. Similarly, the fuel type, take a look at the value counts, and engine also look at this is very imbalanced. Anyway, so we're not going to fix the balancing problem. We're just going to show you, how we encode. Make sure there are no null values. So check for the null values. The number of doors has two places where you have null, and these are the two records where you have the null value in the number of doors column. So what we can do for those null values, we can hard code, or we can look at the most frequent value in number of doors column. So most frequent value is 4. So you can substitute that 4 in the null value. Okay, so right now we have no null values there. Similarly, number of cylinders, again, this is kind of disbalance here, but again, we're not focusing on that aspect. So the first method is very easy, which is find and replace. That means we are going to create a dictionary mapping of columns, let's say number of doors. The existing value, wherever is 4, make it digit 4. Wherever is 2, make it digit 2. Similarly, for number of cylinders also, if it is 4, make it 4, and so on and so forth. Okay, so in this case, it's quite easy. It makes sense to use numeric representation, and then use pandas with the replace method, and in the replace method, pass the dictionary, and it's going to take the dictionary. Make sure in the dictionary we have the column name exactly mentioned. So after doing so, you will see number of doors column has been converted to numeric representation. Similarly, number of cylinders also is converted to numeric representation. Another method is called label encoding. Let's say we're going to pick this column, body style, and in the body style, the column is object type. Now, for label encoding, you have to make that object column as categorical. So that's a typically a pandas requirement, not necessarily in other platform you'll have to do the same. But for pandas, this object column body style has to be converted to category. So by making it a categorical, data type, then you can apply the codes, which is the label encoding on that particular column. So right now, after applying this, I'm creating additional column, and it's going to take the values in the body style and just randomly put 0, 1, 2, 3. Now, this kind of encoding is really not, useful for, predictor column. You can use label encoding for the output column where you have classes. One hot encoding is a very popular method, or it's called dummies method also. So for example, let's say you're passing the values to series, and this is how the series is based on the values here, A, P, N, and all that. And then when you apply get dummies on this series here, it's going to convert that column into equivalent number of columns to the number of distinct values in this column. So there are 3 distinct values, A, N, and P. So accordingly, get dummies method is going to create 3 different values, and for corresponding places is going to put 1 wherever it is. A is 1 and P is 1 here. So under P is going to put 1. So that's the dummies method. Now you can apply this on the drive wheels column here, forward wheel, rear wheel, and all wheel drive. And you can apply the get dummies method on this column, and you notice it has created 3 different columns here. And accordingly, it will place 0 and 1. Now, this is a very popular method, but there are some downsides as well. So when we discuss machine learning, we'll talk about the impact of the dummy method. So that's the easy example here. The next one, let's take a look at the frequency encoding. Frequency encoding means based on the frequency. So let's say, you have a column with these values A, B, C, and that's how the column looks like. Just do a count here for A is, 4, and C is appearing 3 times, and B is appearing 2 times. and that's the value count. So you can normalize the value count. That means you're going to take the percentages, and that's the frequency encoded. So you can create another new column, and based on the normalized output, you can represent A with 0.44, B is 0.22, and so on and so forth. So that's how you do a frequency encoding. So this example is similar to the previous one, just that you have multiple categorical column here. And for each of the categorical column, just do the same value count and normalize. So essentially, it's going to convert it to the percentages. And after that, you can create new columns here. So that means for category A, this is the equivalent encoded column. For category B, this is the equivalent encoded. You can also have a mix of category and one hot encoding, let's say. And let's say these are the two columns, and you can choose to use category encoding and one hot encoding methods separately. So process each of the column. This is one hot encoding here, and this one is category encoding. So both of these are separate steps. You need to combine these two, and then finally have the representation. Target encoding is a slight variation to frequency encoding. Let's say now you have to have target, and then we have these categorical columns. So this is how A, B, C, and the target is 0, 1, 1. So what we need to do here is this time we'll use a package, and this package is installed using category encoders. So make sure we have this package installed, and then we call the target encoder from this package. And then call the target encoder, pass the data like a normal, Python training. So you pass the training set, and if when you convert the test set, it's going to convert the test set using the training data. So this is how we use the encoding. I hope the walkthrough of the demo was quite easy. I'll be attaching the code sample. So that was a demo on encoding techniques. We looked at a couple of methods: label encoding, find and replace, one hot encoding, frequency encoding, and target encoding. And next topic is going to be scaling. So that's pretty much it in this video. We'll see you in the next session.